Analytical method. Let us consider two wave trains of equal amplitude A and slightly different frequencies N1 and N2 traveling in a medium in the same directions. Let the time-dependent variations of the displacements due to two sound waves at a particular location be S1 equals to R sine omega 1, T equals to R sine 2 pi N1 T. Equation 1. And S2 equals to R sine omega 2 T equals to R sine 2 pi N2 T. Equation 2. According to superposition principle, the resultant displacement S at the same time T is S equals to S1 plus S2 equals to R sine pi N1 T plus R sine 2 pi N2 T. S equals to R of sine 2 pi N1 T plus sine 2 pi N2 T. Equation 3. Using trigonometric relation, sine C plus sine D equals to 2 cos C minus D by 2, sine C plus D by 2. We get S equals to 2 R cos pi of N1 minus N2, T sine pi of N1 plus N2 T. S equals to A sine pi of N1 plus N2 of T. Equation 4, where A equals to 2 R cos pi of N1 minus N2. Equation 5 represents the amplitude of the resultant wave given by equation 4 clearly. The resultant amplitude A changes with time. The amplitude A will be maximum when cos pi of N1 minus N2 of T equals to max equals to plus or minus 1 equals to cos k pi. Therefore, pi of N1 minus N2 of T equals to k pi, where k equals to 0, 1, 2, etc. or T equals to k by N1 minus N2. Hence, the amplitude of resultant wave and therefore resultant intensity of sound will be maximum at times. T equals to 0, 1 by N1 minus N2, 2 by N1 minus N2, 3 by N1 minus N2, and so on. Time interval between two successive maxima of sound equals to 1 by N1 minus N2 minus 0 equals to 1 by N1 minus N2. That is, frequency of maxima equals to N1 minus N2. Again, the amplitude A will be minimum when from 5 cos pi N1 minus N2 T equals to minimum equals to 0. Therefore, cos pi of N1 minus N2 T equals to cos into 2k plus 1 into pi by 2, where k equals to 0, 1, 2, 3, and so on. Or pi of N1 minus N2 of T equals to 2k plus 1 pi by 2. Or t equals to 2k plus 1 by 2 n1 minus n2. Equation 7. Hence, the amplitude of resultant displacement and therefore resultant intensity of sound will be minimum at times. T equals to 1 by 2 of n1 minus n2, 3 by 2 of n1 minus n2, 5 by 2 of n1 minus n2, and so on. That is, frequency of minima equals to n1 minus n2. Comparison of T values for maxima and minima intensity shows that maximum and minimum intensity of sound occur alternately. Combining 6 and 8, we get frequency of beats equals to n1 minus n2. That is, number of beats per second equals to difference in frequencies of two sources of sound. Fifth, experimental demonstration of beats. To demonstrate the formation of beats experimentally, we take two tuning forks, A and B, of exactly the same frequency. Mount the forks on sound boxes and place them so that open ends of the boxes face each other, as shown in figure. Attach a little wax to the prongs of fork A and set the two forks, A and B, into vibrations. Beats can be heard distinctly. On changing the amount of wax, number of beats per second can be changed. At some stage, when amount of wax attached is such that the frequencies of two forks differ by a number greater than 10, beats can no longer be heard as separate.